So again, one of the things I want to emphasize is that rules, when dealing with measurement, it is important that you understand that your number that you present in your data has a level of error in it already based on the estimates that you make. And whenever we deal with these kinds of numbers, it's important for scientists to be able to propagate that amount of uncertainty in the results of the lab. So you're like, what the heck does that mean, Mr. Moranto? So the idea is this. If I say something is 13.2 meters, and then I do something where I measure something again, it's 12.3 meters, something different, and I say find the area between those two numbers, you're going to wind up multiplying those two numbers. And you're going to get a number in your calculator that's going to have more than 3 digits that I presented in the beginning. 13.2, 12.4 meters, those all have 3 digits in them. And your calculator is going to give you a number with more than 3 digits, and if you write all the digits down, you're basically not saying, you're saying it's going to be more accurate than it really is. So let's deal with the rules for sig figs. So the rules are, first thing is all non-zero integers always count as significant figures. So anything between 1 through 9. So any number between 1 through 9, any number between 1 through 9 are non-zero integers. And so 3,456 meters has 1, 2, 3, 4 digits. And so we say it has 4 sig figs. So all of them count because they're all non-zero digits. On the other hand, when we talk about zeros, zeros make up the most complicated part of the Sig Fig rules. And zeros, of course, have different rules. Anytime you have leading zeros means the zeros are in the front, they do not count as significant figures. And so anytime you have a number like this, you say, oh, I have a 0 that's leading, I have another 0 that's leading. These are basically what we call placeholders. We're trying to communicate that it's a very small number. And because it's in the front, these do not count. I have my non-zero digits. Here's 1, there's 2, there's 3. Since we said that all non-zero digits always count, there would be 3 sig figs in this one. So this one would have 3 sig figs. In the next one, zeros, of course, captive zeros. So when we talk about captive zeros, these are zeros that are in between non-zero digits. So 16.07 has 1 captive 0 in the middle. And anytime it's captive, whether there's a decimal or not, doesn't matter. I am, as long as I'm in between non-zero digits, that captive 0 always counts. So this would actually have 4 sig figs, 1, 2, 3, 4. And so we'd have 4 sig figs for this number. The next zero rule is what we call trailing zeros. And trailing zeros are significant only if the number contains a decimal point. So what does it mean to be trailing? That means it's at the end of the number. So when we talk about trailing zeros, we have 4 different scenarios here. The only time they are significant is if it contains a decimal point. So here I have a decimal point. So because I have a decimal point and I have trailing zeros 1 and 2, that means 1, 2, 3, 4, all of these numbers count. And that decimal signifies that those are important, so we count those. That's why that one has 4 sig figs. On our next number, this time I don't have a decimal. That is a comma. That means these zeros right here do not count, which means my 9 and my 3 are the only numbers that count. Therefore, I have 2 sig figs. In my next number here, looks like I have a leading 0, and we said leading zeros never count, and I have a trailing 0. So which 0 counts? Well, since I have a decimal, that means this counts. The 2 count and the 3 count, so I have 3, 2, 0. There's 3 sig figs on this one. And then last but not least, I have no decimal again. I have a 0 that's trailing, no decimal. That means I only have 1 sig fig. 2 is the only one that counts. So this is how we count with trailing zeros. So the next rule is exact numbers. So we talked about all the zeros. Exact numbers have what we call an infinite number of significant figures. And the reason why we have this rule is because when we have conversions, you want to make sure you know that because it is a conversion, it has infinite number of sig figs. It's not going to affect the number of sig figs of anything you multiply, divide, add, or subtract. So what's an exact number? 1 inch equals 2.54 centimeters is considered exact. And so whenever you use this in a conversion, these numbers do not affect the sig figs of the results. And so you can't count this as 1 sig fig because that's really infinite number, 1.000000 all the way to infinity, and 2.540000 all the way to infinity as well. These guys are exactly defined, and therefore this is not 1 sig fig, that's not 3 sig figs, they're both infinite sig figs. And again, that'll come back into play when we talk about conversions. And so let's do some practice. How many sig figs or how many significant figures in each of the following? So I want you to pause right here and count them yourselves. And at the end, I will show you the answer. Okay, so thanks for pausing. So let's look at the very first one. If I were looking at this very first one, what I see is I have zeros that are captive because between the 1 and the 7, and I have 0 that's a trailing 0, and there is a decimal, which means basically all those zeros count. That means I have 5 sig figs on this one. On the second one, I have again another trailing 0, and again I have a decimal, which means that 0 counts. That means I have 4 sig figs on this one. And then this next problem over here, I've got a captive 0 again, and I've got a trailing 0, but because there's no decimal, this 0 doesn't count. That means I only have 5 sig figs on this one. Here, I don't have any zeros, and if you ever see scientific notation, do not multiply it out. That's rule number 1. All you do is pay attention to the numbers in the front, and you can see there are no zeros to worry about, so therefore this only has 3 sig figs. So even if you would have multiplied this out, you might have actually thought that this only had 3 sig figs, but because if that 0 moves one, if you add that 0 to the end, and you might think the decimal is at the end, you might think that's 4. In scientific notation, all that matters is the number in the front, so just remember that. And then in the next problem, you can see I have a decimal, and I have 1, 2, 3 zeros that are what we call leading zeros. Some of you are thinking, well, isn't this captive, the 2 zeros here? And the answer is no. As long as there's no whole number integer, like 1 through 9 integer in the front, and only have a 0, this decimal does not make it captive, so therefore this only has 2 sig figs. Last but not least, if you look at this, I've got 1, 2, 3, 4, 5 zeros that are trailing again, no decimal, so therefore all that really counts are these 2, so I only have 2 sig figs. So hopefully you got that correct. That's the end of this lesson for now, and we will basically talk about the rules for multiplication and addition next. If you have any questions, please feel free to come and see me during lunch or after school.